In this video, we're going to be talking about the notes that cover the metric system as well as graphing. So to start us off, let's talk about the metric system. First off, because it is science, when we talk about anything related to mass, which is the amount of matter that's in an object, we will be using the base unit of gram, which is represented by a lowercase g. It is important to make sure we keep that g a lowercase. The second thing, when we talk about length, we'll be using the basic unit of the meter rather than the foot, and that is represented by a lowercase m. And then finally, when we talk about volume, or the amount of space something takes up, we'll be using the liter, which is represented by an L. Now, while G and M need to be lowercase, L can be lowercase or uppercase, it doesn't matter. Now, with the when we talk about using the metric system has our basic unit, the meter, liter, gram, and then we have these prefixes that we can add to represent a different value of that number. So just like we can talk about length in terms of foot, yards, miles, inches, we can talk about length in terms of meters, kilometers, hectometers, decameters, etc. Each prefix represents a different value. Kilo means 1,000. So if we have a kilometer or a kilometer, that means that there's 1,000 meters. If we have a hectometer, that means it's 100 meters. Deca, think of like a decade, represents 10, so that would be 10 meters. Then we have our basic, which could be a meter, a liter, or a gram. If we keep going down, just like there's inches with foot, so if foot was our basic, then this would be inches. But we have deci, so we could have a decimeter, which is 1/10 of a meter. Centi, which is 1/100th of a meter. And finally, milli, which is 1/1000th of a meter. Now, I keep saying meter, but it could be kilogram, kiloliter, decagram, decaliter. Any of these can have that prefix added to them. So the way we convert between the prefixes is we use what's called the ladder method. First thing you do is you're going to determine your starting point. Then you're going to count how many jumps it takes to get to the end point. And then from there, move your decimal the same distance. So for instance, if I wanted to convert 1 kilometer, or actually let's look at a kilogram, just so we remember that we can do meters, liters, or grams. If I wanted to convert 1 kilometer into a decimeter, I start at kilometer and it takes me 1, 2, 3, 4 jumps to get to deci. So that means if I had 1 kilometer, and because it's a whole number, that means that the decimal point is after our whole number. I'm going to move my decimal point 1, 2, 3, 4 places. So this is my new decimal. And every one of those jumps, I'm going to fill in a 0. So that means that 1 kilometer, or sorry, I keep saying kilometer, 1 kilogram equals 10,000 there we go, decigrams. And sorry, my handwriting is not awesome on the computer. So 1 kilogram is 10,000 decigrams. And we can move in the other direction as well. So for instance, if I wanted to go from a centiliter, so say I have 1 centiliter, and remember liter can be lowercase or uppercase, and I want to go to, let's just go to a basic liter. Then I would go 1, 2 jumps. So that means I had 1 centiliter. I move my decimal 1, 2 to the left because my jumps were to the left. fill in that 0. So 1 centiliter equals 0.01 liters. So depending upon the direction you move determines the direction you move your decimal. However many jumps you have to do to get there, that's how many spaces you move your decimal. And that's how you convert between the basic units, or between the prefixes. So another way to remember this is if you're moving to the right, your number is going to get bigger. If you're moving to the left, your number gets smaller. Okay, so take a second now and go ahead and pause the video and figure out what 4 kilometers is in meters. Okay, our starting point is kilo. Our ending point is meter. And we want to figure out how many jumps it takes. It takes 1, 2, 3 jumps. So my decimal places, and we go 3 to the right, so my decimal will move 1, 2, 3 to the right. So it's 4,000 meters. All right, last slide for talking about metric system, and then we're going to get into graphing, is measuring length. So we have 1 centimeter. When we're looking at a ruler, we're using the centimeter rulers. 1 centimeter is 10 milliliters, so 10 millimeters. So if I was to measure this line, this would be 2.8 centimeters or 28 millimeters. All right, next we're going to talk about is graphing. First off, when we talk about graphing, we're going to talk about tails. Each letter represents something. T represents the title. Your title must be scientific, clear, and concise. Now remember, we want to make sure it is scientific. The easiest way to go about doing this is to write your dependent axis, so whatever the title of your y-axis, versus your x-axis, which is your independent axis. So what this means is, say if I was doing height of average height of an 8th grader over the course of the year, my y-axis would be my average height, the x-axis would be the month of the year. So my title would be height of 8th graders versus the school year. That would be the scientific title. A represents axes, which means that your axes should be straight. Now obviously this is a bad example because when I drew my x-axis it was not very straight. So whenever you're making these by hand, make sure you use a ruler. I represents interval, which is each tick mark on your graph. What is the space? What is the numerical value between those? Whatever you start with, you need to make sure you keep that consistent as you go down your axes. So for instance, if I start with 2, and then I skip 1, and I go 6, and then I would skip another 1, then this would become 10, because each tick represents 2 points, or a value of 2. So 2, 4, 6, 8, 10. Now my x and my y do not have to have the same values. They don't have to have the same interval. So my y, I might decide to go by hundreds. And maybe I go, each tick mark represents 100. So 1, 2, 3, 4, and then this would be 500. As long as my y is consistent within the y and the x is consistent within the x, that's what really matters, less so the actual numbers themselves. Next, and this is the labels. You want to make sure your x-axis has, your x and y-axis both have labels. And when you're doing the label, not only does it have to have a label, but it has to also include the unit. Numbers without units are worthless. We need to make sure we know what those values are. And then finally, when you're doing it, you want to make sure the scale of your graph fills the graph paper. That's really important, that you actually fill the total space. Okay. All right, now let's talk about types of graphs. There are 3 different types of graphs that we will be using in science. The first is probably the one you're most familiar with, which is the bar graph. You can have a single bar graph, a double bar graph, a triple, quadruple. There's no limit to the number of bars. What matters is that a bar graph is used when you're looking at categories. So in this case, the category is the age of the people. In this second graph here, the category is which teacher you're looking at. So when you're categorizing something, then you're going to use a bar graph. The amount of homework that this teacher gives in no way affects this teacher, so that's why we can use the bar graph. They're independent values. The second type of graph is the line graph. And again, you can have a single line graph, a double, triple, quadruple. There's no limit to the number of lines either. But for this is when you want to plot every single line on every single point along that line. Remember, a line is just a collection of points all put together. So this means that the data physically goes through all of those data points. So when you're looking at something that's changed over time, like if we're looking at temperature, you can't change from 86 degrees to 78 degrees without passing through every other temperature along the way. So when you have continuous data like that, that is when you're going to use a line graph. And then finally, we have the scatter plot. This one is looking for a correlation or a trend. What is the trend when we're looking for a relationship between the data? So in this example, we're looking at how does weight and height relate to each other. Well, based upon this data that's collected, typically as height increases, so does the weight. What this means about being discrete data points, it means each one of these data points, in this particular case, is a specific person. So this person has this height and this weight. This person has this height and this weight. And again, one person's height and weight in no way affects another person's height and weight. And while there is a general trend that as you get taller, you get heavier, notice there is a lot of variation because people are different. So with a scatter plot, we don't connect the dots, but we do add in what is called a trend line or a best fit line. Excel calls it a trend line. You can also hear it called a best fit line. Basically, this line represents the average of the data. Half the data is above the line, half the data is below the line. It's physically showing that trend so that someone could look at this data and they could say, all right, if I was this height, I would be on average about this weight. So the trend line, sorry, I know this isn't very straight, but the trend line allows us to determine or quantify or make an estimated guess about where a person's weight would be if they were that height. And so those are the 3 graphs that we will be working with throughout this year.